All right, welcome everybody to second day school. Today we're going to be talking about a lot of important things. We're going to be going over kind of an overview of how programming works, like how that process works. We're going to be going over how to print things to the screen. We're going to be going over how to make variables, and we're going to be going over how to read variables from the keyboard into a variable. So today is a very important lecture. We're going to pause at different times during the lecture to give you guys a little bit of lab time, where you can write code yourself and check to see if you can do it. So for those of you watching the YouTube video at home, basically there will be times where I'm going to be like, okay, now write a program that prints, something to the screen. I'll pause. That's a moment when you should pause the recording and see if you can do it on your own, if you can do the thing that I asked, and then come back and I'll show you the answer. Okay. So we're going to go over 4 things today. We're going to go over what it means to compile a program. You might have heard this before. We're going to compile a program. The program's compiling right now. We're going to talk about what that means. We're going to talk about how to use cout to print things to the screen. We might even show you something new and fancy called println. Maybe even println, which is a new thing in C++ 23. We're going to show you how to make a variable, and we're going to show you how to make a couple different kinds of variables. How to make integers, floating point numbers, and strings. And then finally, we are going to show you how to read things from the keyboard into a variable. This is a very foundational class. This is, if you look at all the bullet points there are in computer science, this is half of them. So you guys are learning half of all computer science today: variables, I/O, and algebra. Should probably add algebra into here too. Algebra. We're gonna go over that today as well. Okay, very important lecture. Let's get going. So if I hop over to the server here, there is a text file, and if you guys become somebody, I want all of you guys in like your hello world directory and to vim main.cc. If you're watching this at home, just type this from scratch. There's lots of websites that have compilers that just work online. There's cppsh. If you go to this website here, you can actually type a C++ program into it and hit run, and it'll compile it and run it, and you can enter things. And so if you don't have a computer at home with a development environment set up, cpp.sh is a great site for doing that kind of stuff. But for now, if you're in my class, obviously go into main.cc inside of hello world, and you'll see that there's some starter code here already. And there is one line right here where you guys are going to be writing your code. Okay. I'm going to hop back out. I'm going to hop into... Did it freeze? See, people... I can tell when people just vimmed into this because... the first time you run the new development environment, it installs a lot of stuff for you. So the thing is going to hitch until everybody finally gets that open. So I'd like for you to write a program that looks exactly like this. Cout hello world. So this is the only line that you're missing there. Now your code has a return 0 on it. You can delete that if you want. It's not really important. What this program is going to do is when you run it, it's going to print the words hello world to the screen. So I'm going to leave this up while you guys copy this, and I'm going to talk about the compilation process a little bit. This is a text file. So when programmers work making programs, simple programs, complicated programs, we're almost always working inside of a text editor of some sort. The program is sort of held in text form. And you can't, if a text form that describes what World of Warcraft will do or something. It's millions and millions of lines of code. And that's not something you can double click on, and run. So there's a process called compilation. Compilation is the process of going from a text file to an executable. That's what compilation is. So whenever you hear me say compile the code, what that means is go from the text file. The text file is called main.cc, and it's going to make an executable, something that can run. And we do this on our server by typing compile main.cc. The first time you run this, it's going to ask you for your username and for your email. You can actually type anything you want in there. Currently, that doesn't do anything. Later on, we're going to integrate your student account with GitLab, probably. How do you get off the laying dragon screen? You logged in, change your password. Yeah, when you log in for the first time, it's going to print a little message of the day using cout hello. So it has a dragon print a little message to you. You can clear the screen if you want by hitting Control L. If you want, Control L clears the screen. If you want to hide the dragon. If you want your cow to be in colors, you can do that as well. It's kind of fun. It's kind of fun. All sorts of fun you can have with cow. Your lover will never wish to leave you. The lunatic, the lover, and the poet are of imagination all compact. So, anyway. So what we're going to do is we're going to compile main.cc. That goes from the text file into an executable. And then that gives us an executable called a.out. A.out in Unix systems is the default generic name for a program. If you don't give it the name of your program, it will create a program called a.out. And you can see that a.out was created. 245 is 38K in size. And if I run it by just typing a.out, then it will print hello world to the screen. So the steps are, you edit your source code, you edit it, goodbye world, Shift-CZ, save and quit, compile it, run it. And you can see the program has now changed. You're going to be doing these steps over and over again this semester. And if you're a computer science major, you're going to be doing these steps over and over again for the rest of your life. You edit a file, you save it, you compile it, you run it. Hey, did that do what I want? Nope. Okay, let's edit it again. That's the development cycle. That's what you're going to be doing over and over again. Okay. So what I'd like for all of you guys to do now is to see if you can add emoji to the words here. So, for example, you can change the text so that it says, I would like to eat. And on a Windows machine, Windows key period brings up the emoji. Oh no, I'm not eating cats. No. I'm gonna eat it. Let's not do that. Let's do ramen. Let's do ramen. Yes, that is, everybody loves ramen. So see if you can go ahead and add some emoji to your string there. String is computer science terminology for words. So see if you can make a program that says, I would like to eat ramen, or I don't know, do they have waffles? They have waffles, excellent. And let's see, what else? What else do we want to eat today? Pizza, or what else am I in the mood for today? Sushi, maybe? Yeah, let's do that. Let's get some sushi in there. Okay, so that is going to be your assignment for the next couple minutes. See if you can write a program that includes that. Remember, it's Windows key period, Windows key period to open the emoji screen. And then you save and quit, compile, run, and see if you can get some emoji up there. This is how you print things to the screen. I'm going to go ahead and pause the recording now and see if you guys can figure out how to do that. All right, and we're back. So we got some interesting things of what people want to eat. Let's see what we got here. Eggs and toast, maybe? It's hard to see. What is that? Toast and eggs. We got somebody who's trying to melt my face off in light mode. Coconut shrimp sushi. All right. Sorry, I'm blind for a second there. We got burgers, fries, and a milkshake. Very cool, very cool. Were you guys all able to compile it, run it, see it, print the emojis to the screen? Colorado Grill, yeah. Sorry, just got flashbanged by Pitts over here. Okay. So you can also do these on multiple lines as well. So if you want to have different lines with different things on them, you do that as well. And this is going to print basically what you can see up here. It's going to first print, I would like to eat ramen. Then I'm going to eat waffles. Then I'm going to eat sushi. Maybe that was waffles that we saw. Waffles and eggs. So the way that it works, when you run a program, when you compile a program, it creates an executable. When you run the executable, what happens is this. Step 1, that's the line of code that runs. So inside of C++, the entry point, the beginning of your program, is a function called main. And the open curly brace right here is the sort of starting line for your program. So when you run the program, the very first thing that runs is the first line in main. A line of code in C++ ends with a semicolon. So the semicolon is like the end of the line. White space actually doesn't matter. So if I were to do something horrible like this, this code is exactly the same. I mean, it's ugly, but it's exactly the same from C++'s perspective as what we had before. I'm kind of getting a brain aneurysm from looking at this, but if I were to compile it and run it, you can see it runs exactly the same way. C++ doesn't really care about white space at all. And so, maybe I should put this back before my brain starts bleeding too much. But the line does not end until you get to that semicolon there. After the first line of code runs, then C++ moves on to the second line of code and runs that one. And then it's going to print, I would like to eat waffles to the screen. And then it moves on to the next line, where it says, I would like to eat sushi. Then we have now hit the bottom of main. We have a closed curly brace. That's the end of the program. It quits. We're done. Everything's cool. So some people write return 0 at the end here. That's fine. It does the exact same thing as before. You'll see there's absolutely no difference in the program. And in fact, there is no difference in the compiled program. It's exactly the same. That's why I don't write the return 0, because technically, according to the standard, you don't need it. A lot of, Zybooks, I think, doesn't know that. So if you see the Zybooks code, they generally are going to have the return 0 there. I don't write code that is non-functional, so I usually leave it out. But if it makes you happy, put it in. It makes no difference. More power to you. If you're wondering what that 0 means, the 0 there means the error code for the program. And so if I were to change this to, 60, when I run the program, exactly the same thing happens, but it has returned error 60. So what does that mean? Nothing. What does the operating system do with it? Nothing. So what difference does it make? It doesn't make any difference. It could. You can make it make a difference. For example, if I echo the return code from the program, it'll echo 60. So if you're doing like workplace automation, like Nico here does a lot of workplace automation, what you can do is check to see if the previous program errored out, and if it did, stop. Right. So like if you try my compile shell script, each of these things is a different program that runs, and if any of them report an error, it stops. So for example, it runs easy peasy to see if there are any mistakes in your code. Then it runs CPP check, a tool by Google. Then it runs the compiler. And if any of those steps fail, then it stops the entire script. So for example, if I come in here and, make a compiler error like that, then you'll see my shell script detected an error was returned, and it says, there's a problem, I'm going to quit now. So these error messages can be used, but by default, they're not. And so you will very rarely see me return 0 or return anything. It's mostly non-functional, especially at the level that you're at. So, but if you want to put return 0 there, because all the cool kids are doing it, knock yourself out. Okay, so another question I got is what does this thing mean, and what does this thing? What does include IO stream mean, and what does using namespace std mean? So IOStream is a library that allows printing to the screen, essentially. So the cout here and the end line here are part of the IOStream library. And so if you want to print things to the screen, you have to hashtag include IOStream. The end line, by the way, is like hitting the enter key. It's like hitting the enter key. So if I take out that end line, what you're going to see is this line here be attached to that line there. Let me show you what that looks like. So you can see we got the ramen, and then it immediately goes on to I would like to eat waffles. Right? Ramen with no enter key, it just goes to the right. You guys understand? So the end line is like hitting return, hitting enter. So put one of those in whenever you want to go to the next line. You guys understand? Does that make sense? You could have everything on one line if you wanted. And now it's all kind of horrible. You're still confused how to put an emoji in. So when you're in insert mode, so if you're in insert mode, hit Windows key, period, and then the emoji. Ooh, we got fencers here. We got a chicken, fencer, sword, cake, cat. If you're not using Windows, it'll be different, by the way, Madison. So the other question I got was, what does this line of code here do? What that means is it makes your code look a little bit nicer, essentially. So without this line of code here, you would have to write code that looks like this. And some people prefer writing code this way, some people don't. So cout is part of what's called the standard library in C++, and so its full name is std : cout. Endline is also part of the standard library, so it is std : endline. I personally don't like having STDs in my code, so I don't think it contributes anything. It just adds 5 extra letters that are unnecessary. Anytime I see the word cout, I know that it's the standard library's cout. I've never had any issues with this. However, you'll find people online that get really mad if you do this. So just be aware that some people love STDs. They want STDs all over their code, everywhere, at every chance they get. Personally, I don't. I try and remove as many STDs as I can because this is perfectly readable and understandable, and nobody has any confusion about what this means. So I just use using namespace standard up at the top of the code, and then that allows me to pull all of those essentially meaningless 5-character things that clutter up my code. I get to pull them out. But like I said, you will see people online that do not do that, and they prefer this. This is what they prefer. They prefer their code looking like this. It's up to you. If you want to write your code like this with STDs everywhere, knock yourself out. More power to you. If you like it looking this way, which is my own personal code preference, more power to you as well. So it's just a style issue. They will argue till they're blue in their face about how dangerous it is, because you never know what cout you might be dealing with. But I always know. I've been programming C++ for a really long time. It has never been an issue for me. Okay. So that is that. Yeah. So main is the entry point into your program. And this is kind of like how you're going to start most of your programs, because pretty much all of your programs are going to print to the screen. And most of your programs are, depending on your personal choices, you're probably going to want to have a using namespace standard in there or not, depending on whether you like STDs or not. So, there is a new thing. This is new in 2023. And for those of you at home that don't have access to my server, this won't work for you because it's not out yet. But there is a new option, a new hotness and it's called print and println. So this is a brand new thing, brand new for 2023. So you guys are the first class that has the opportunity to make hello world look like this. So there is a print function and there's a println function. So the print function looks like this. And the println function looks like this. So print is like writing cout hello like that, no inline. Println is like that with an inline. Do you guys see the difference here? So print doesn't hit enter. Println hits enter. That's the difference between print and println. And so this will cout hello to the screen, and this will cout world to the screen, then hit enter. So if we compile this code and run it, you will see we get hello world that way as well. So it's a little bit more compact than using cout statements. It's just, again, a personal choice. You can see that Hazelton on the channel has, or Lewis, I think, on the channel, has posted a poll whether or not people, so this is from the previous class, but you can see he's putting up a poll whether or not people like the new C++23 thing, or if they like the old way. What we had in the previous class is Oi bruv, and Diamond Hands, Rocket to the Moon, you know, Wall Street Bet style. So, which one do you guys prefer? Just out of curiosity. Do you guys like the new way better? Do you like the old way better? You're not going to offend me. They're equivalent. And again, a lot of times you'll hear me say this in this class. A lot of times things just come down to personal style decisions. This class, I don't grade you on style. Your grade does not matter, you know, whether or not you cout or println, or if you indent or not indent or name variables differently. I do not grade on style. I grade entirely on correctness. And so, I mean, imagine like you're working for Chase Manhattan. You know, your customers don't care what your variable names are. They care, did, you know, you accidentally delete $1 million from their account. You know what I mean? What matters is correctness, that your code actually behaves properly. And of course, style feeds into that. But if you can make your code behave properly with STDs, or if you can make it behave properly without STDs, either way, it's fine. It behaves properly. So, do they just borrow println from Java or Python? Yeah, sure. Used to cout, you'll stick with that. Old way, because you're used to it. Cout out of habit. Either way is fine. Like I said, either way is fine. And you will see people make all sorts of questionable decisions online. Like it's pretty common, for whatever reason, for students to submit code like this that has no indentation on it, and that kind of hurts. That kind of hurts my brain. Or people using light mode, or you know, coding like this. That's a little better, I guess. Everything is new to you. Yeah, any way you get it to work is all good. Some people do their curly braces like this. Some people do it like this for some reason. I'm not even sure what kind of monster puts the curly braces in the middle like that, but some people do. It's like a style some people like. I can't handle it. I would probably, yeah, I would silently judge you, I think, if I saw code like that. You can do it though. It's like it's your code, you know. As long as you can make the code work, that's all that matters. But just be aware that I will judge you, you know. Or if I don't know, do something like this. If you do something like that, I will not be silent in judging you. perfectly valid C++, but I will probably not keep my mouth shut on that one. But for most reasonable things, for most reasonable things, like if you have an indent there or a open parentheses there, I honestly don't care. Okay, what will he judge you on? I think compile program formats their code anyway. It does, in fact. One of the secret things that I've done is like if you do like screw up your indentation or whatever, screw up your indentation, i.e. not do it my way, look, it fixes it. So I actually have my shell script reformat your source code the way that I like it, so that you learn proper style. But again, it's not something that's graded. Okay, so do you guys understand how to print things to the screen? Either println or cout. Is that pretty reasonable? I think the next thing we need to get into is variables. Okay, you got it. All right. So there are 3 variables. So learning points for today. I like to make notes of these things so you can kind of see what it is you're expected to know. Number 1, the compilation process. In other words, edit a text file, compile it, run it. Edit a text file, compile it, run it. Edit a text file. Those 3 things in a loop over and over again. And compilation means going from a text file to a program. That's where the magic happens. That's where your thoughts get translated into reality. Number 2 is how to output to the screen using cout and println, or we should say, or println. You don't have to do both if you don't want to. And then number 3 is variables. Okay, so there are 3 kinds of variables that we're going to be working with today, at least. They're probably the most important 3. And these are ints, doubles, and strings. So an integer, so you make a variable in C++. You have to make a variable before you use it. Some programming languages, you don't have to do that. In C++, you not only have to make a variable before you can use it, you also have to tell C++ what its type is. A type is what sort of data the variable holds. So an int holds whole numbers from about negative 2.1 billion to about positive 2.1 billion and change. A double holds scientific notation numbers from, I don't know, we to epic, and a string holds words. Okay, so how do we do it? How do we make a variable? We covered input to in person. Yeah, we'll get to that. So integer x equals 42. So here is how you make a variable. There's 4 parts to this, 5 if you count the semicolon. Remember, every line of code in C++ ends in a semicolon. The semicolon tells you where the end of the line is, not white space. White space doesn't matter. So there's 4 parts to this. The first thing is the type, in this case integer. So that is telling us that the variable named x is going to be holding whole numbers. So integers include 10, negative 20, 0, 500, negative 6,000, whole numbers only, integers, including 0, positives, negatives. So the type is integer. Then we have the variable name, which in this case is x. The name of the variable is the hardest part in computer science. So coming up with a good variable name is absolutely the hardest thing to do. In practice, like right now I'm calling it x because I got no better ideas right now. But in practice, you're going to have, like, I don't know, if this is the score for team 1, then we call it score team 1, something like that. You want to have a variable name that tells people what you're holding. So it makes sense. Because if all of your variables are like x and y and z and c and a and b, nobody has any idea what anything is, right? So giving it a good variable name is a core part of making your code understandable. But I'm just going to put this back to x because I don't know what this variable is. It's just it's demo code. I'm just showing you guys how to make a variable. So I got nothing better. X is a good default name, if any. Then you have the equal sign, which means set x equal to, and then the initialize or something like that. Semicolon. Okay, in this case, 42. So this is going to create a new variable named x. Its value is 42. Its type is integer. There's also a memory address in RAM that is kind of secretly created inside of there. So it also is secretly given a RAM address where its home is, its location in RAM. You don't really see that right now, but you could get it if you wanted to. And then now we got a variable. So what kinds of things can we do with a variable? Well, we can print them. So if I see out the value of x like this, what do you guys think this will print to the screen? What do you guys think? So we're making an integer named x, whose value is 42. I'm printing the value of x to the screen. What's going to print? It'll print the value you initialize it to, which is 42. Right? Some students get confused here and they're like, oh, it's going to print x. Nope. It prints 42 to the screen. Good. You guys got it. So if you don't believe me, I'll run it for you right now. You can see it does, in fact, print 42. We can make two variables if we want. So we can make a variable y that is equal to 420. And we can print multiple things at once as well. So the comma here allows you to declare and initialize multiple variables of the same type at the same time. So if you're going to have like points for team 1, points for team 2, points for team 3, and points for team 4, you put it on 4 separate lines, or you can use commas and put them together on one line. Just kind of depends, whatever is more readable for you. So this is making two integers. Y is an integer as well. You don't repeat the int, by the way. Everything in the comma list is going to be an integer. So if we added z here, -10, x and y and z are all ints. They're all integers. Whole numbers, including 0, positive numbers, negative numbers, that are in the range between 2 billion and -2 billion. Okay. So if we see out x and a space and y, what is this going to print to the screen? Cast your votes now. What is the highlighted line right here? What is that going to print to the screen? What do you guys think? That is correct. 42 space 420. So you can chain together multiple cout statements like this. And it's going to first print x, which is 42. It's then going to print a space. It's then going to print y. And then it's going to hit the enter key and go to the next line. Let's do one more thing here like this. What is this going to print? Now see, this might be a little tricky for you. Raise the difficulty slightly. What is this going to print to the screen? Did I put a space between the y and the z? That's the tricky part right there. I did put a space here between the x and the y, but I did not put a space between the y and the z. So if I run this, you will see I, in fact, get 42 space 420 minus 10, which most of you guys got. Very good. Okay, so that is that. We can make doubles as well. So we can make a double pi equal to 3.1415. We can make double we negative number as well. And I can see out pi followed by the inner key, followed by we, followed by the inner key. So what do you think this line of code is going to print out to the screen? Now this time I put an inner key in the middle of it. All right, doesn't just have to be a space. This is perfectly valid C++ code. So what do you guys think this is going to print to the screen? Enter your votes now. Operators are standing by. Remember, doubles can hold decimals. Integers cannot. Integers cannot hold fractions. Cannot hold decimals at all. You can hold very large numbers using doubles. You can hold very small numbers using doubles. All right. We got one vote from Falconer, and we got Beza entering his vote now. So it is going to print, in fact, both of these lines, 3.1415 and negative 0.01. You don't know how to put it under. If you hit Shift-Enter in Discord, then you can enter the enter key that way. Okay. What if I output, we're getting into algebra now, what if I try outputting 2 times pi? I'll just get rid of the Nintendo Wii. What if I try outputting 2 times pi? What is 2 times pi? Anyone know the name for 2 pi? 2 times pi? Have you guys ever heard of the name for twice the value of pi? Like there's some YouTubers that are like, we should just use that instead of pi. It's called tau. It's like a capital pi. It's 2 times pi. 6.28. All right, so what is that going to print to the screen? Double pi. Pi. I actually just picked up a strawberry rhubarb pie from Julian Pie Company when I was in San Diego 2 days ago. So, a circle, exactly. It's a perfect circle. Judith Marie. Okay, 6.283. Very good. All right, and then there is one other type of variable that we need to learn, and that is strings. So strings name is equal to min Corelli. Cout name. It's the name of your TA, of course. What is that line of code, the highlighted line? What is that going to print to this screen? What string is going to appear on the screen when you print this string to the screen using cout? And you are all correct. That is in fact going to print min Corelli to this screen. This string containing min Corelli gets printed to this screen. Yes, I can speak. Okay, and so you can have multiple names. You could have name2, or you could have first name, Justice. You could have last name. So what is this going to print to this screen? What string is going to get printed to this screen now? So I declared the variables last name first, first name last, but I'm printing first name first, last name last. So what is this going to print to the screen? Justice min Corelli. Very good. So if we compile that, run it, yes, Justice min Corelli is in fact what gets printed to the screen. So strings hold words, doubles hold decimals, ints hold whole numbers. There are many more types in C++, but these are kind of like the 3 most important ones. It's going to cover a good 80% of all of your use cases, I think, can be covered with these 3 things. Any questions about it? In the previous class, a person was like, why don't we just use doubles for everything? Anybody here want to ask that question? Anybody here know the answer to that question? Because it seems like doubles are a little bit more useful, right? Like integers are limited to negative 2 billion to positive 2 billion. It's not that, I mean, it's big, but it's not that big. Like there are people whose bank account balances, I'm sure, are higher than 2 billion, you know? Uses more RAM. Yeah, technically a double uses twice the RAM of an integer. But the reason why we actually don't use doubles very often at all. Doubles are typically only used in like games and scientific simulations and things like that. In programs, just when we need to hold a number, we almost always use an integer instead. And the reason for that is because integers are precise. They do not have error in them. No error. Has error. Okay, so every time you add two doubles together, it's only guaranteed to be accurate out to the last decimal place. You might add 200 and 200 and get 400.01. Or you might add 200 and 200 and get 399.999999999. And that's bad. Because like you might have your code say, well, if the answer is 400, do something. And 399.999 is not 400. And then your code breaks. And you don't know why. And you run through the math. I've done this before. You run through the math, you run through the algebra, you're like, all the math, all the algebra checks out. This should be working. And what's actually happening is that you're getting very small amounts of error. If you add together a lot of floating point numbers together, error will accumulate over time. And you will not get the number that you think. If you add together 1,000 numbers and then subtract out those 1,000 numbers from the total, you don't get 0. I mean, you might, but you probably don't. You guys understand the problem here? You know, like you add 1,000 numbers together, and then you go through the list and subtract them out of that total. Algebra says the answer should be 0, and you end up getting like 0.2 or something. You know, maybe not 0.2, but you get like not 0 as the result of it. Algebra doesn't hold. It's not commutative. You know, if you multiply two numbers in a different order or three numbers in a different order, you can get different answers. If you cancel out a multiplication and a division, you'll get a different answer. Slightly different, but different. And so doubles oftentimes are more trouble than they're worth. Your bank definitely does not want to use a double to hold your bank account balance, right? Because they do not want to accidentally give money to people and invent money out of thin air, right? So ints are like actually a lot more common than doubles, even though doubles on the surface seem more useful. You can have a very small number like 0.01. You can have a very large number like 10 to the 20th power. You know, like it's got this huge range, positive, negative, scientific notation, very large, very small numbers, but they have error in them. And so most computer scientists steer clear of doubles unless you're doing like science or simulations and things like that. Okay. Can you add instant doubles? You can, and you get a double as the result. So there's actually rules. That's actually a really good question, Vanessa. What happens when you mix things of different types? And the general answer is it converts the answer to whatever has the most precision. So if you have like a 16-bit integer and a 32-bit integer, and you add them, you get a 32-bit integer. If you have a 32-bit integer and a 64-bit integer, and you add them, you get a 64-bit integer. If you have an integer and a float, you get a float. If you add an integer and a double, you get a double. If you add a float, which is a 32-point floating point number, and a double, which is a 64, a float and a double added together, you get a double. Whatever has more precision is what you get as the answer. That's the general rule. There's a couple sharp edges in there that screw everybody up. The most obvious one is when you add an unsigned integer to a signed integer. So for example, I can make, this is a little bit afield, but I can make an unsigned integer named Bob. Unsigned integers, hold values from 0 to 4 billion and change. So integers are normally negative 2 billion and change to positive 2 billion and change. An unsigned integer is only positive, 0 and positive. And so there is like this little sharp edge. If you add a normal integer and an unsigned integer together, you get an unsigned, which feels backwards from how it should be. If you add negative 10 and 10, you end up getting 2 billion. Which, yeah. So my advice for you as a new programmer is to stay away from unsigned integers because their interaction with integers it's a very sharp edge you will cut yourself on. So just don't worry about it for now. The three, but great question. Yeah. In general, the three types you need to know are int, double, and string. That will take you through 80% of this class, the whole semester. All right. So now we're going to talk about algebra. So let's do a little algebra up in here. So if I see out x plus y, what do I get? There are 5 algebraic operators. Algebra. There is plus. There's minus. There is multiply. There is divide, and everyone's favorite child, modulus. We'll talk about it in a second. So if I see out x plus y, what do I get? What's going to print to the screen? $462 is correct. What if I do x minus y? Why don't I make the numbers smaller? Let's give me 1 second. Let me make these a little bit easier. I'll get rid of z2. We'll just do this. Okay. What is 10 minus 20? I hope you guys can all do this in your head. 10 minus 20. Yeah, right. You're right. Negative 10. Very good. What is negative 10 minus negative 20? Negative 10 minus negative 20. Negative 30. It is 10, right? Minus is plus. So this is negative 10 plus 20. Okay. Not negative 30. So minus is a plus. Same rules as in algebra. Okay. That's kind of what I'm trying to show you guys here, is that all the rules of algebra, all you know, the please excuse my dear Aunt Sally, all the order of operations, all that kind of stuff is all the same. So if we say 5 times y, so what is, okay, this is gonna be too much. Okay, let's get rid of the negatives. Okay, what is 10 minus 5 times 20? What is 10 minus 5 times 20? Order of operations. Which one happens first? The multiply or the minus? Maybe I should make it a little harder. There we go. Space it out a little bit more. So which one takes place first? The multiply or the minus? Multiply. Very good. So it's going to do the multiply first. So it's going to go 5 times 20 is 100. 10 minus 100 is negative 90. Okay. What if I, please excuse my dear Aunt Sally, and put a parentheses like that? Now what are we going to do? What we got now? Parentheses evaluate first, right? They evaluate PIMDOS, parentheses, exponentiation. Okay. So 10 minus 5 is 5, times 20 is 100. We got 100. Good. All right. So we got plus, minus, multiply. Now we got divide. Now divide is the part where we're coming to an area that will probably be on your final. Division and modulus in integer world are different than, might be different from what you expect. So remember, in integers, there are no fractions. Okay? There's no such thing as 2.1 in integer world. In integer world, you have whole numbers only. So what is 10 divided by 20 in integer world? What is 1/2 in the world that doesn't allow for 1/2s? What is 1/2 in a world with no fractions? Some people are saying 1, some people are saying 0. Are you saying 1 because you round up? Like 1/2 rounds up to 1? 0.5 is not allowed. You cannot have 0.5 in an integer world. In the world of discrete mathematics means the mathematics of integers. There are no fractions, there are no decimals. You have 0 and you have 1, and that's about it. So, error. 1. Okay. Do you guys remember 4th grade? When you did long division? So, how many times does 20 divide into 10? Do you guys remember that? Where you have like that weird division symbol that you never used after, elementary school, like this thing. You know what I mean? Like, when was the last time you ever did like that? You know what I mean? Like never, right? Right, you have the quotient, and then you have the remainder. And that's what you get from these two bad boys right here. So the quotient of integer division is, like in long division, how many times it divides in. And the remainder is this guy. So this guy is called the modulus, the remainder operator. That is the leftover bit. So how many times does 20 divide into 10? 0 times. So 20 divides into 10 0 times. Okay. So 20 divides into 10 0 times with 10 left over. You guys remember that from like 4th grade? You cannot have a negative remainder, right? And the remainder you can't have a remainder of like 20, right? Like the remainder has to be between 0 and 19, right? Because if you divide by 20, if you have another 20, you get one more. You know what I mean? Like 40 divided by 20 is 2 with a remainder of 0. So you can't have a remainder of 20. The remainder is always going to be between 0 and 19. So if we make this, I don't know, 55. So how many times does 20 divide into 55? So 55 divided by 20 is another way of saying it. 20 divides into 55 how many times? You guys remember long division? 20, the little weird wicket looking thing there. 20 divides into 55 2 times. And then you do the long division. 2 times 20 is 40. And you subtract 55 minus 40. What is the remainder? What is the remainder? 2 with a remainder of 15. Right? 20 divides into 55 2 times with a remainder of 15 left over. This is something that gets students all semester long. And it's because you don't, in math classes, you don't do discrete math up until 3rd semester computer science. And so, you learned long division originally back in like 4th grade, right? Where you're doing integer division, but you have not been doing integer division for the past, 10 years of your life or however old you are, right? Like, think about it. All the division you've been doing till then, after then, has been like fractions and decimals, and you can't even do modulus with a decimal number, right? Like it won't even compile. Like look at that. Like you cannot do modulus with a double, right? Because like 5.3 divided by 1.7 is actually I don't know what it is. Should have picked an easier example. 5.3 divided by 1.7 is 3.11. Like there's no remainder. Like there's no, you know what I mean? Like it doesn't make any sense to have a remainder It just divides in 3.117647 times, right? The modulus operator doesn't even make sense. It can't compile. It won't work if you use it with decimals. Only works with integers. And so this gets students all year long. And the reason why it gets them all done all year long is because imagine you were doing Pokemon. So let's say that you have a Pokemon with an offensive score of 190, and you're attacking somebody with a defender score of 200 with a power 50, 60 attack, whatever. So the way that it works in Pokemon is, let's say your attack normally does 50 damage. It gets multiplied by the ratio of offense to defense. So if my offense is twice your defense, my attack deals double damage. It would do 100 damage instead of 50. But if your defense is twice as high as my offense, then I would do half damage. So instead of 50, I would do 25. Do you guys understand? Like there's a ratio between offense and defense, and that gets multiplied on top of the power. So the Pokemon damage is equal to offense divided by defense times power. You guys understand? So if defense is twice as strong as offense, you do half damage. If offense is twice as strong as defense, you do double damage. That makes sense, like conceptually. And so if we like output this, in fact, this is valid C++ code, not you. There we go. How much damage is this going to do? We're doing 50 damage. The offense is very close to the defense, right? So what would you guys estimate? Like 48 damage, 46 damage, 49 damage. It's pretty close. Offense is almost tied with defense. What do you guys think? Cast your votes now on chat. How much damage do you think this is going to print to the screen? 47, 48, 0. 50. 47. We'll do 0 damage. This is a bug that affected probably 2/3 of my students in the Pokemon assignment last year. The reason for that is because what is 190 divided by 200 in integer world? How many times does 200 divide into 190? 0. And so this part here inside of the parentheses is not 90% or whatever. It is 0. And so it does 0 times 50, which is 0 damage. And yeah, believe me, like, you know, students will sit there and stare at it for like an hour and be like, I have no idea why this stupid thing isn't working. And this is why, you know, I'm telling you right now, it is a mistake that, you know, new students make all the time. In integer world, division only gives you whole numbers. Okay? So 400 divided by 200 is 2. 600 divided by 200 is 3. You don't get any fractions though. So 610 divided by 200 is still 3. You just get even whole numbers. For every 200 you have, the answer goes up by 1. And we do not have a full 200 here, so the answer is 0. And contrawise, like if it was like, you know, 300 divided by 200, the answer is 1. So it should have been doing 50% more damage, but 300 divided by 200 is 1. And so it was doing no extra damage. And again, students just get very baffled by this. And the reason for that is because in integer world, there are no fractions, there are no decimals. Whole results only. Are you guys with me on this? This is something that will be on your final. So prepare yourself for that. Isn't there a function that changes that? Yeah, you can work around that. Like if you make it a double, Welcome to flavor country. Answer is 47.5. There you go. You want decimals? Make it a double. All right. It's the easiest thing to do. And there's other ways of converting between integers and doubles and things like that you can do. But that's, that's perfectly acceptable. If you want decimals, make it a double. Simple. So, okay. So variables, there's algebra. And then finally, we are going to do input. Input. How to read things in from the keyboard. So, it looks like this. That output to the screen looks like this. Variables, x equals 42. Algebra, x is equal to 10 plus 20. Input. Reading from the keyboard. All right. So if we have integer, let's do a string. We haven't messed with strings yet. Name. We're gonna do first name, last name. Cn into first name and last. This is going to read two values at once. Maybe this is too complicated. Let's start with one. Okay, cout, please enter your first name. We're going to read it in, and we can say welcome to paradise. First name. So this code here is going to print to the screen. Please enter your first name. It is then going to pause. And so when you get a cn statement, cn stands for console in, which means the keyboard. If you guys ever wonder which direction the arrows should be, you can think of the direction of the arrows as the direction that data is flowing. So these words here are flowing to the console out. The console out is the screen. Here, data is flowing from the keyboard into your variable named first name. So it's going to pause, and it's going to wait for the user to type something. And once it types something and they hit return, then first name will contain the first word that they typed in. And then it will print to the screen, welcome to paradise, Bill, or Justice, or whatever we type in. Yep. Please enter your first name, Bill. Welcome to paradise. What is your name? Vanessa. Welcome to paradise, Vanessa. What is your name? Justice. Welcome to paradise, Justice. Okay. So what I'd like for you guys to do is to ask the user for their last name first and first name last. A little bit of lab time, like 5 minutes of lab time. I'll put on Big Iron again or something along those lines. Lab time. Ask the user for their first name and last name, then print them out backwards. Last, first, last. You understand it? Not like reversing Bill to be Lib, right, and Kearney to be Yerknab or whatever. But, just print first name last name first. So whatever order you ask for it in, print it out in the opposite direction. So I'm going to give you guys enough time for me to play one song for you. And then I will unpause the recording and look at your answers and show you my answer. Okay, begin. All right, and we're back. Let's take a look at a couple sample solutions here. See out. What is your first name? What is you first name? Utterly unplayable. F. What is you first name? String first name, last name. CN into first name. What is your last name? CN into last name. You sure have an ugly mug. Last name, comma, first name. Beautiful. I love it. 100%. Okay. Next up, we got string first name, last name. See out. Give first name. Give first name. CN first name. Now kindly provide last name. last name. See how last name and first name. So, yep, looks good. All looks good to me. Let's look at one more. First name, last name, last name. Welcome to Paradise. Yeah, I mean, you can delete that line. We don't need that. But yeah. So what you're missing there is, okay. So let's see, y2y, paste. By the way, what I just did there was y2y, which copies 2 lines, followed by a P to paste below. Shift P pastes above. And then B goes backwards a word. W goes forwards a word. D, 2W deletes 2 words. D3D deletes 3 lines. So a lot of good Vim stuff in here. So I'm just gonna I'm tapping W to jump forward a word at a time. Here, DW, last. And then, ooh, this will be fun. Well, whatever. 5S, last. And then we can say, welcome. Last name. First name. Justice. Curly. Welcome in Curly Justice. Probably should put a space in there. Huh? B. David. Medina, David. Okay. No space there. One more time. There we go. Okay. Madison. And then it looks good. Okay. So that is how you can do input. You can do output. We can do a little bit of algebra too. In fact, let's close out today with maybe doing a little bit of algebra. So you're on Friday is going to be our first lab time. So you're going to get your first programming assignment on Friday, and it'll be this kind of stuff. And basically, what we're going to be doing this semester is the online section is especially challenging to teach, simply because if somebody doesn't do anything, like there's no way that I can see, like, are you in front of your computer? Or are you just, at Taco Bell? Which happened before. So what we're going to do is for lab time on Friday, I'm going to give you guys work to do, and you're going to have to turn in something by the end of lab time. And you will get points based on how much of the homework that you've completed by the end of lab on Friday. And it'll be a full homework assignment. You'll have more time than just the lab to work on it. But one of the best ways to not procrastinate on a assignment is to start working on it. Like once you work on it and you get momentum going and you understand what's happening, a lot of times you just want to finish it. Like, okay, I'm 2/3 of the way done. I could just finish it, And if you don't do that, then students tend to wait to the very last minute. And then if they get stuck, they don't know how to save in Vim, they don't know how to compile, whatever, then it turns into a train wreck. They get a 0. Everyone's unhappy. So what we're going to be doing this semester is basically forcing you to start your homework on Fridays when homework is given. And you will get points for how much work you get done on the Friday during lab time. So you have a class over Unix question when you get a second. Fire away. Ask questions anytime you want on chat here. You can also post memes. It's all good. Like one of the nice benefits of this layout for doing lectures is that you can ask questions, and when I take a breath, I finish a thought, I can look over and answer your question. So if you can complete 100% of the assignment during the lab, will you get a higher grade than if you complete 66%? In theory, yes, but in practice, no. It kind of depends on how do I want to put it? How much is reasonable to get done in an hour, right? So if the homework assignment is like a 40-hour, a 40-hour assignment, I don't expect you to finish 66% or 100%. You know what I mean? I'm going to have a certain level of expectation. If you meet that level of expectation, you get points, basically. And then if you go under that level of expectation, I might throw you some mercy points or something. So, okay. Demonstrate good faith effort. Yeah, basically it's like, I'll have an idea by the end of class, like how much you guys can get done in an hour, and score you based on that. So yeah, but like, yeah, if you get 100% done, you're going to get whatever the maximum is. And I might even give you extra credit for finishing it in an hour. So there's that too. Okay, so here is your final lab time. So put this into a Vim cheat sheet here. Cheat sheet. What are some other good Vim things, Really? Copy, paste, X deletes a character. A appends the end of the line. So if you want to like if you want to jump to the end of the line and start typing, that's something people do a lot. Shift A is your friend. Shift I inserts at beginning of line. Caret and $sign jump to beginning and end. What else? Yeah, double left arrow left indents. So left arrow 8, left arrow left indents 8 lines. That's actually what I just did right up here. Right arrow 9, right arrow right indents 9 lines. Left arrow 4, left arrow left indents the next 4 lines. Pretty useful stuff. GG equals capital G reformats entire file. If your code formatting gets all screwed up. Shift Z saves and quits. :Q exclamation mark quit without saving. That's a good one. Like if you screw up pretty badly, you're just like, no, I accidentally wiped out everything. :Q exclamation mark is good for that. Okay, so lab time. Lab time is going to be a little bit of input, a little bit of output. Okay, so lab time. Create 3 double variables. CN into them. Principal, interest, and duration. And CN into them, asking the user for each one, like, please enter interest now. And then compute some equation, like compute principal times interest times duration divided by 12. I don't know, it's like months or something like that. Cout the result. Okay. Interest. And maybe the interest rate divided by 100. So if they put in 5, then it'll be 0.05. And this will be like some sort of financial planning kind of thing. It's not a real equation, but you can pretend. You have work during class time. That's fine. For those of you that have situations where you're working, message me, and I'll work it out with you. Mostly what we're trying to avoid is last semester where we had students be like, okay, it's lab time, start working on it. And then they just disconnected from Discord and didn't come back. And we're like, okay, you're not actually doing lab time. You know what I mean? Like, like the whole point of this is so that you can get practice while I'm here, where I can help you. Also, what we'll be doing is you'll be sharing your screen so I can see what you're working on, and we can help you and stuff like that. Because the way you get good at programming is by coding constantly. You just have to code and code and code and code and code and solve problems, and you just get better and better. And the students last semester who were just like disconnecting and just like, nah, I'm just done, whatever. They're cheating themselves, but we're going to try and give some extrinsic motivation this year to try and encourage people to be here during lab time. And like I said, if you're working, Shin, just contact me. We'll figure out some other way of you getting those points. Okay. So that is lab time. I am going to go ahead and pause for now. When we come back at the end of class, which is in 12 minutes, I believe, I will show you the answer. Okay. Begin now. And we're back. So this one looks pretty good. So first line of main, we're declaring 3 variables, named principal, interest, and duration, initializing them all to 0. Very nice. You will see online, by the way, some people will not initialize their variables. We don't talk to these people. They're bad people who should feel bad about themselves and shame. So, yeah, every time you make an integer or a double, you should always initialize them. And if you don't know what value it should be, just initialize it to 0, like the person's doing here. They then output, please enter principal money. They see in the principal, see out, please enter interest. Inputting the interest, please enter duration. Inputting the duration. See out money after duration at a rate of da, 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 da. And we got a algebraic equation here, which is principal times interest divided by 100 times duration divided by 12. In line. Looks good to me. Brilliant. Now this one, you can see that the error you're getting here is saying use of undeclared identifier. Now, one of the worst parts of C++ is the error messages that make no sense to you until you've done computer science for a couple of years. So an undeclared identifier. What the hell is an undeclared identifier? Like, it means you didn't make a variable. So remember how we talked about what a variable declaration was? In C++, you must declare a variable prior to being able to use it. And so what is missing here is that line saying double principal equals 0. And so if you put that on top there, that error would go away. Likewise, if you declared interest, that would go away. If you declared duration, that would go away. And then here, your cout is backwards. So you see how it put a little underline underneath the double right arrow. The O stream, the arrows go to the left. The data flows from the text here to the screen. Cout is the screen. The console output is the screen. The data goes into the screen. To display it from the keyboard, the data flows from the keyboard into the variable to read from the keyboard. And the rest of this looks fine. So whenever you get an error like this, and you don't know what it means, ask me, or Mincarelli, or Hazelton, or any of the other experienced students around here. Because in all honesty, the errors are often baffling. So, there is no shame in asking. In fact, when I talked to Bjarne Strustrup, the guy who made C++ about this, I'm like, hey, how do you explain error messages to students? He's like, I just have them ask. Like when they're confused, just put up your hand. Hey, what does this mean? So, yeah. So just remember double principal equals 0, interest equals 0, duration equals 0. Always initialize your variables. Don't be this person. Don't be the person that doesn't initialize a variable. Always initialize your variables. That's just good practice. See into them. All right, so cout, enter, print, duration. I don't want to type the whole thing. Then semicolon, cn into principal, interest, duration, and then we will cout so 10, 10, 10, I don't know. There we go. All right. Whatever that means. So that is our first real class of programming today. We have covered half of all of the topics in computer science in one class lecture. So if you don't feel confident about this, don't worry. This is your first day of programming. You will be doing this stuff over and over and over again until it becomes second nature for you. So make sure you get the Zybooks done by tomorrow night. And then there are the Zylabs that are coming up in, I think, a few days. And then make sure you're here on Friday for the lab. That's it for today. So thank you all. Peace out. I'll see you on Friday.